Hi, everybody. Here is lesson 5 from Unit 6, and this lesson is covering properties of logarithms. We have covered exponentials already, which are the inverse of logs, and now we're going to cover how to switch between the two, starting with a log, and then how to apply the properties of logs. There are 3 main properties we're going to use today, and then one more that we're going to cover that we'll go over next time with our equations. Up at the top here, it's similar to what I just said, I'm just going to read it to you. It says, since we've already taken a closer look at exponentials and exponential equations, we will now do the same for logs and logarithmic equations. Remember, logarithms are the inverse function to exponentials. And for something to be the inverse, you just swap the x and the y. Below, we can see what it looks like to invert one to the other, as well as how similar properties of logarithms are when compared to the blank that we reviewed in Unit 5. If you look down here, here's our properties of logs. You can see we have one called product, quotient, and power. Those are all names that we have and use for laws of exponents, which is what we covered in Unit 5. Nice review back in Unit 5 from freshman year. And there we go. Up here at the top, we're just going to cover how to label all of the parts of a logarithm and a exponential. And then for E through H, we're also going to practice swapping between the two. We'll look here first on this side. We're on the left side, starting with A. A says label the base and xy. Base, and then you have a point x comma y. You can see here we have log base 49 of 7 equals 1/2. And if you just compare it right here, let's look at those two. You can see here the little number is that one right there. That's base. The base is 49. The inside of the log is x. In this case, that would be 7. And it's equal to y. In this case, that's 1/2. So what this is saying is log base 49 of 7 is 1/2. Another way to say that goes along with our exponential over here is 49 to the power of 1/2 equals 7. I'm going to show you how to check that in the calculator as well. I'm going to use the graph, even though we're not going to graph it, because for this button to push, you need to have the one that has a space here to be able to put the base. And when you do just the scientific one, it doesn't show up on there. So I'm scrolling down here. I'm going to look for log with the space for a base. And I have it right here. Under EXP, it has log base A. And now you can see the little flashing cursor, so you can put in 49 and then push the right arrow until you're inside. The inside is 7. And according to our paper, it should say 1/2. We got 0.5. I'm just going to push the fraction button there, and it is, in fact, 1/2. So you can always double check these in the calculator. One of our practice questions will just be putting these in the calculator. Or you can do them off the top of your head if you want to try. If you want to figure out 49 to the power of something equals 7, you can just kind of brainstorm what that number would be. And that's what it looks like. Next one, down here we have labeled the base and xy. This one says ln 32 equals 5. This is not mathematically correct. I realized it the other day. It's like 3 point something, not 5. We're just going to pretend, let it go. But I am still going to label. There we go. And this ln stands for natural log. So ln equals natural log. And natural logs have a base of e. Remember, e is that number we learned about during our word problems. It indicates continuous compounding when you're looking with word problems. And e is really similar to pi. It is a letter that represents a specific constant number, and e is 2.718 and some change. There's more after that, but I haven't memorized that far. So for ln, our base is always e. We just don't ever write it down in the question. And then what this says here is that the base e to the power of 5 equals 32, which, like I said, is not exactly correct. It is a little bit off. But the 32 would be x, and the 5 would be y. Okay, let's look at these two. We're just gonna go look at the other way. We're still gonna label base and x and y. Oh, sorry. There we go. There. Now, according to here, we're just gonna follow this model here. Base is the big number that has an exponent and it's equal to x. So for this one, our base is 4. Our x value is 16. And our exponent is 2 because 4 squared is 16. Do the same thing for D here. Base and then xy. Our base is 7. It is something that's being raised to a power. 7 to the power of 3 is 343. So here our y would be 3 because that's our exponent, and then we are equal to 343. Let's see that right there. Good. The next 4, we're going to practice labeling and then switching. So let's go ahead and just mark it out. I'm going to do it like this so I have some more room. Now, according to here, I'm just going to copy the structure there. Copying that. You can see the little number here is the b, the base, so our base is 81. The inside of the log right here is x, which is 3. Oh, I almost wrote x again. And then it's equal to y. Our y is 1/4. And then we're just going to try to rewrite it. And we want to rewrite it in this format here. So I want b to the power of y equals x. B is 81. Y is 1/4. And x is 3. And again, if you have it, you can always double check in the calculator. You could type in 81 to the power of 1/4 and it will tell you 3. The stuff you check in the calculator, you could always check stuff that doesn't have any variables in it, and it should give you a number. Good. The last one we have here on this side is G. This one does not have a base on it, but it doesn't say LN, so it's not going to be E. Its base would be 10. Remember, if there's no B question mark, B equals 10. So unless you're working with an LN, which the base is always E, if you have the word log, its base is going to be 10 if there's not a base written down. So this says log base 10 of 10,000 equals 4. So our base is 10. I'm looking back up here. X is the inside, and we're equal to y. So x is the inside, that'd be 10,000, and we're equal to y. And then we'll rewrite it, just like we have it right here. So b to the power of y equals x. B to the power of y equals x. And a lot of times there's no other way that would actually make sense, right? If we tried arranging that a different way, it wouldn't make sense because the 10,000 would be in the wrong spot. So you can also think of it like that as well. Perfect. Our last ones are going the other direction. So we're still going to label bx and y. But this time we're going to switch to log. So look in here, comparing to here. Our b is the big number. It's a 9. Our exponent is y. And it's equal to x. And then to rewrite it, we'll write it as a log. The log says y equals, y is -1, equals the log. And the base is 9. And the power, or 2x, or of x, is actually probably the right word to say, is 1/9. So I feel like my 9s look a little wonky. That's a 9, and that's a 9. There we go. And that's how you do it. See if you can do H, and then come back when you're ready to check it. Here is H. Our base was 8, our x was 64, and our y was 2. And when you rewrite it, you would have y equals the log of the base of x, which is 64. Okay, at the bottom here, now that we've practiced going back and forth and identifying stuff, we're going to look at the properties. Remember how I said these are linked to our exponential ones? I'm going to go over these three here, and we'll save this one for the next set of notes. We have product, quotient, and power. The product property of exponents says that when you have things being multiplied like that, then you add their exponents together. If you look at this one, see how it's similar? We add and multiply. For quotient rule, the quotient rule of exponents says if we are dividing, then that's the same thing as subtracting our exponents. You can see here we are dividing and subtracting. And last but certainly not least, we have power. The power rule says that if I'm raising something to the power of something else, then I'm going to multiply my exponents like that. And you can see here, we are eventually going to then multiply the power times the other thing. So let's look at it with logs. Each of these is going to have a couple steps, so we will do the first step, and then once we get to power, we'll go back. I'll explain that in just a second. So the power rule says that if we're multiplying things together, like we are here, two bases together, then we're going to separate them with the plus sign. So the log of x to the sixth, y to the squared, y squared, is the same thing as saying log x to the power of 6 plus the log of y squared. Next, looking at quotient, we have the log we're dividing. And it says if we're dividing, then we can also do the numerator minus the denominator. So we have log base 2 of 17 over v to the 8th. That's the same thing as saying log base 2 of 17 minus log base 2 of v to the power of 8. And our last one here, power, says that if we have something raised to an exponent, we can also just multiply that exponent times the log. This obviously doesn't have an exponent. We can rewrite it as if we have one to try to simplify. So if you have the log base 6 of 81, we could also say that that's 9 squared. And then per the power property, what we would do is just move that exponent. Sorry, that was a really big hump. Move that exponent here to the front, and it would look like this. 2 times the log base 6 of 9. And this would be how it was expanded. That's called expanding it. You can see we could have done that up here. That's why I left us a little space here. So let's try doing that for this one as well, this top one. So on our product rule, when we do have x to the power of 6 and y squared, so instead of saying the log of x to the power of 6, we could also say 6 log of x plus 2 log of y. And there we go. And then on this last one here, well, the middle one, we have 17. 17 is not able to be written with an exponent. So what we're going to do is just look at the second one. So you have log base 2 of 17 is not going to change, minus, and then here we can obviously move that 8 is an exponent down here. So 8 times log base 2 of v. And that would be our answer. And that is how you expand. You could also go the other direction. If you were to start here, you could also work your way backwards to here. It would be called condensing. And we're going to do both of those on this page here. So our top 4 are expanding. We know that because we're starting with 1 log, and we're going to move our way out to multiple logs. And then the bottom 4 here, we're starting with multiple logs. We're going to condense down to just 1. On this bottom here, none of these have an X or a W or whatever. I forgot to include one of those, to be honest with you. So on these, because they don't have any variables on them, you will be able to see if you could also simplify the answer down to just one number, and I'll show you that as well. For these, because we're expanding, obviously we're not going to simplify to one number. So let's look at number 1 and number 2, then you can try 3 and 4. So number 1 says log of 4x squared. So you have the log of 4 times x squared, so we could split these up per the product rule. Product rule says if we're multiplying two things, we could also add them together with their own log. And it would look like that. And then per the power rule, if we have an exponent, it can also become the coefficient. Like that. And that would be our simplified answer. Okay, let's try this one. This one we are dividing. Right here we have a numerator and a denominator. So we're going to use the quotient rule to get rid of that. And the quotient rule says if I'm dividing, I could also subtract. It looks like that. And then they both actually this time have an exponent. So per the power rule, if I have an exponent, I can also make it a coefficient. So instead of saying log base 8 of x to the 1/2, we can say 1/2 times log base 8 of x minus, excuse me, 3 log base 8 of y. And there we go. Perfect. Okay. Follow the same steps and try number 3 and number 4, and then come back when you're ready to check it. Is 3 and 4. On number 4, I did put parentheses. I just don't, personally, my brain doesn't like the look of the LN before the numbers. It makes my brain a little confused. So I do like to put these in parentheses. You can, though, use parentheses for all of them whenever you want. They're just not required if you only have one term. Next time we'll look at questions that have 2 terms. So it'd be something like this. Like that. You would have to have parentheses around that if you had 2 separate terms. If you just have one term, it's fine. You don't have to have parentheses. Here's what we're looking like. Okay, let's do the next one. We're going to do the sides this time. So we'll do 5 and 7 together, then you can try 6 and 8. On number 5, these are just numbers, so we will be able to try to simplify all the way down. And we are already expanded, so we're going to try to condense this time. If you look here, we have a plus sign. Plus sign tells us we're going to use the product rule. And per the product rule, if we are adding logs together, we could also combine it into one log and multiply what's on the inside. And this would give us log base 6 of 36. Here, you can always check if it's a whole number by typing in the calculator. You could also kind of walk through the step of thinking how to switch back and forth, right? We don't know what this is equal to, but we do know that this to the power of something is equal to this. So 6 to the power of something equals 36, and that something is what we're looking for, and that would be 6 squared is 36. So the answer would be 2. The way you can check this, I'm going to show you in the calculator. Just like before, I'm going to use the graphing one because the other one doesn't let you do one that has a base, its own base. So we're going to push function, scroll down till you see log. Here we go. We have log base 6 of 36. And it says 2. There you go. So if you have no variables, you can always check in your calculator to see what the answer is. Let's look at the next one down. This one is a little different. It's just an extra step. We have a 2 out here. To be able to combine these logs together, like we do over here in our properties, you'll notice none of them have a p in front, like this, because you have to move the p back before you can do it. So you can only work it with this kind. So here, I'm going to move this 2 back first. So per the power rule, I'm going to move this guy back. So this is really log base 2 of 8 squared minus log base 2 of 2. And then now we can use the quotient rule, which is if we're subtracting, we're going to divide. So per the quotient rule, it's really log base 2 of 8 squared is 64 over 2. I got the 2 from right here. And then we'll keep going from there. That's a crazy looking for. Okay. Oh, we have log base 2 of 32. And remember, we're trying to figure out 2 to the power of something equals 32. That's what number goes over here. Or you can just type in your calculator log base 2 of 32. We'll show you that here. Perfect. So here we scroll down. So we find log base 2. And then put the 32 on the inside. That was the wrong number. And we got 5. And there we go. And that's how you do it. If you had one, again, that did not have just a number, had a variable, then you would stop trying to simplify. Obviously, if you had an unknown value, we'd just leave it here. Perfect. Okay. See if you can do 6 and 8. So pause, try 6 and 8, and then come back when you're ready to check it. Here is 6 and 8. For number 6, you should have gotten positive 3 because the log base 4 of 64 is 3. And then for number 8, you should have gotten 4 because the log base 2 of 16 is 4. Good. Let me write one in the middle here, just in case you're still a little confused on the variable one. Let's say you had something that looks like this. Like that. If this is the question that's given to you, what you would do is get to here, and then here. And from there, obviously, you couldn't plug anything in, so this would be the final answer, because I think our practice has more of these. So that's what that looks like if you just have variables and not numbers. Perfect. Hope this helped. Have a wonderful day. Bye.